Monday to Friday. 9 a.m. till 12 p.m. This is Today with Kino Kamis
on Cape Talk.
Your time now, 23 minutes to 10, and you are joined by none other than Chris Smith, the Naked Scientist. A very good morning to you, Chris.
Morning, Kino. How are you doing?
Always good. Always good. So we didn't have any homework last week. So what I'm going to do, though, Ross has given us a call, so I'm going to jump straight into Ross in Thornton. Hi there, Ross. Good morning to you. Hold on, what's happening here?
Hi.
There we go.
And first of all, a word of thanks to Chris, because a few weeks ago I asked him a question about storytelling, and he referred me to the work of Dr. Adrian Owen, who I then looked up, and they even managed to get the book for me called Into the Grey Zone, which was an extremely emotional journey for people who have been locked into their brains after trauma. And can't move and apparently can't do anything. My question actually comes from reading some of that book and the realization that different parts of the brain listen to different things. And I was wondering, and trying to put in the storytelling, which I do, was wondering if storytelling with their different topics and different access to different parts of the brain might be eventually used as a form of therapy.
Ross, what we know about the brain is that different parts of it do different jobs. And there are regions that are specialised for moving, regions specialised for feeling, regions specialised for hearing, regions specialised for seeing. But they don't work in isolation. They're all richly connected together. So when you have an experience that stimulates chiefly one particular modality, one particular area of the brain and its role, nevertheless, it does change the activity in other regions. And I talked to someone recently who did this really fascinating study where they looked at people who were blind and had been blind since birth, but they studied the part of the brain that would normally decode vision. When they presented sounds to these people, and particularly a rhythmic pulse of sound, they found that there were particular areas in the seeing parts of the brain that were lighting up and becoming active with the same rhythm as the inputted sound. And this has a number of different connotations and consequences. This, for instance, might be one of the reasons that we can do lip reading, because we tune in visually to what a person is saying just as much as we're tuning in the audio spectrum to what they're saying. So when people create a rich sensory experience, whether that's actually telling a story, making a piece of music, that's why we find that we experience a range of emotions and we form pictures in our own mind facilitated by that particular experience, because the person who's doing this really well is presumably creating the right milieu to recruit all these other areas so that we don't just experience the information in isolation. It's creating this very rich sensory and emotional journey for the listener, the viewer, or the reader to go on. And it might well be that, yes, we can also use this to help people who have particular problems with an area. If you need to strengthen a particular way in which the brain is working, for instance, to rehabilitate someone after a stroke, then yes, you certainly can do certain roles and tasks that stimulate or particularly recruit a brain area. But similarly, because they recruit other brain areas, if you've got a disconnect to an area of the brain, you can still access that brain area via some of these other channels. So yes, I think you're right. You probably can use this therapeutically, and people do.
Well, there we go. Thank you very much for that. That is Ross in Thornton. And I normally start off the show by asking you what you've been up to. So is there anything that jumps out in particular before we go into any other particular questions directed at you, Chris?
Well, quite an interesting story this week that came out from researchers internationally was this question about Venus. And this is the discovery of the gas phosphine, which is a phosphorus atom with 3 hydrogen atoms stuck to it. It looks like a molecular pyramid, this molecule. And the reason this caught astronomers' attention, they made the discovery by pointing 2 telescopes, one in South America and one in Hawaii, at 2 different times at the atmosphere of Venus, which is our next planetary neighbour. It's very similar to the Earth in terms of size, proximity to the Sun, but on the surface, the 2 places couldn't be more different. Venus has got a runaway greenhouse effect. It's about 500 degrees C on the surface. You could melt metal there. It rains sulfuric acid on Venus, so it's not what we would call hospitable, even by the standards of some cities I've visited in the world. Nevertheless, when these researchers pointed their telescopes at the atmosphere of the planet, they saw this light signature corresponding to this molecule phosphine. And you might say, well, what's special about that? There's loads of chemicals in the atmosphere of a planet, for example. The reason this is exciting is because previously, where we have found phosphine, we have found it because it has been made by life. It's one possible hallmark of biology, of life. And while it's possible that around other planets that are gas giants like Jupiter with very different conditions and chemistries going on, that you could make this artificially, rather as in you could make this via chemical processes, it seems less likely around a rocky world like Venus that this could have arisen from just natural processes. What we understand of the chemistry in the atmosphere of Venus makes it harder to reconcile this with just a natural origin for this phosphine signature. Instead, scientists are saying, well, could there be some bizarre form of life floating around in the upper atmosphere of Venus where the conditions are a bit less harsh? Perhaps this is an evolutionary hangover of Venus's past life when it was wetter, less searingly hot, and a more hospitable place for life, and perhaps life has retreated into these upper atmospheric regions, and the hallmark of them being there is this phosphine signature. On the other hand, it could just be that some other chemistry we've yet to disclose is accounting for this. But an intriguing observation, and if it turns out to be true, it will A, be amazing, and B, it will be the closest that we've come to discovering extraterrestrial life. And just to think that it's on the planet next door would be pretty stupendous. But obviously very, very early days, needs confirmation, needs corroboration, needs further investigation. Exciting and interesting nonetheless.
Indeed. Let's go to Charles in Fishhook. And by the way, before we get to Charles' question, remember, you can call in on 021 446 0567 and WhatsApp on 072 567 1567. Just send a WhatsApp voice note message or just type a message, and we'll put that straight through to Chris. Let's go to Charles in Fishy Corner, otherwise known as Fishhook. Hi there.
Hi, Kino, and
hi, Charles.
Chris.
Hi there.
Why is it that years ago when we boiled an egg, we boiled it for about 3 minutes? Now we seem to have to boil it for 6 minutes.
Oh, how long is that? How long you go for, Charles? Because I'm still a 5-minuter actually, but that's something to do with the size of the eggs I tend to buy, because I go for a certain grade in the shop, and especially if I buy the ones from my local shop that are from the farm around the corner, and they're quite big, and I like runny eggs, and I'm confident that the amount of salmonella in eggs these days is tiny, so I'm happy to have a slightly more runny egg. But no, it just varies on how runny you want the yolk to be and how congealed you want it to be. So if you cook it for longer, then the process that causes the proteins and the denaturation reaction that causes the yolk to gel together, that will happen more the longer you cook it for and the higher the temperature. And if you cook it for less long, then the yolk remains runnier, because the chemical reactions and the changes in the chemicals that are provoked by heating, that not as many of the proteins change, so you get less of that gelling effect. So it's nothing special about the eggs apart from their size, because obviously the bigger the egg makes a difference with surface area, access of heat coming in from the water into the interior of the egg, and how much substance of the egg there is to heat up in order to actually get the egg to cook. Another factor is that some people keep their eggs in the fridge, so you're starting with an egg that, rather than being 20 degrees room temperature, say, you're starting with an egg at 4 degrees, and therefore you've got to put in correspondingly more energy to get the egg to the same cooking temperature, and then for those chemical reactions or changes to the proteins to happen. So there's a range of factors, but it's basically what makes your egg taste good.
Well, there you go. Thank you for that one, Charles. Let's go to Nat Van Crawford. Hi there. Whoa, you're going to have to switch your radio off. You can't let's talk to me on the radio and then have your radio on. There's this thing called feedback. Asseblief. Just anybody calling it the show, do not have your radio on. Let's go to Natva in Crawford. Hi, Natva.
Good morning. How are you?
Very good, thank you.
Good. I would like to ask, Doctor, what is homocysteine and what should be the safe levels in human beings?
Homocysteine.
Oh,
right.
homocysteine. Right, okay.
Yes.
This is an amino acid, and I'm not sure what the concentration biochemically in the body ought to be for homocysteine, but there will be what we call a reference range. I suspect if you look up on the internet reference range for homocysteine, you can find out what the normal range is. The bottom line is that any chemical you put in your body will have a safe level and an unsafe level, and it can be unsafe because you don't have enough of it. It can be unsafe because you have far too much of it. Water is great, but you can drown in it. Oxygen is fantastic, but too much of it will poison you. So there will be a published reference range. I don't know what it is.
Okay, brilliant. Thank you for that one, Natver. More of your calls this morning on 021 446 0567. I did say you can go to WhatsApp, and we have a hand sanitizer alcohol question on the WhatsApp. Let's take a listen to it.
Morning, Chris and Kino. I wanted to know what are the differences between the alcohols that people use? So we were investigating whether hand sanitizer contained isopropyl alcohol. We could not get a clear answer because most of them don't have ingredients on it. So I just wanted to know what was the difference. I think you get an isopropyl ethyl and a methyl alcohol. Thank you.
Okay, great question.
Okay, the answer to this one is that what we call alcohol, that's effectively slang for ethanol. Ethanol is a type of alcohol. An alcohol is a hydrocarbon, so it's a chain of carbon atoms, and it's got an oxygen stuck to a hydrogen molecule group on the side. And in the case of alcohol, it's two carbon atoms stuck together, and then this OH, oxygen-hydrogen group. If it's methanol, it's one carbon, and then the oxygen-hydrogen group. If it's propanol, then it's three carbons in a chain and then the OH group. And the longer that you make the chain, the smellier the chemicals become and the nastier that they taste. You shouldn't drink these things anyway. But the reason that they're used in hand sanitizers is because the carbon chain makes them like oily things. And the OH group, the ol, the thing that makes it an alcohol, likes water. And so if you have a solution of the alcohol, it means you can have a proportion of it in water. For example, you can have 60-70% alcohol. And it works as a sanitizer because the hydrocarbon, the carbon bit that likes oil, can stick itself into membranes of cells, and particularly the outer coat of microorganisms like bacteria, and also certain viruses that have an oily envelope around the virus. And if the alcohol molecule sticks its oily chain into that membrane, it can pull it to pieces because it can pull the oily bits into contact with the water that it's dissolved in. And this disrupts the membrane, makes it fall apart, and that destroys the infectivity of the organism. And it doesn't really matter how long that carbon chain is, except that there's shorter chains are practical because they'll dissolve well. And so you can have a solution of the alcohol that is very useful, very practical. You can put it into hand sanitizers and rubs and gels, but it's got a high alcohol concentration. It will tolerate having a high alcohol concentration, which means it evaporates very quickly and your hands dry again, or the surface you've cleaned dries quickly because the alcohol evaporates. But equally, it's practical to use. And it doesn't really matter what the alcohol is, as long as they're one of these short chain alcohols that's fairly easy to work with. They all have this effect of disrupting the structure of the microorganisms and effectively killing them. But it doesn't work against all microorganisms. You have to be careful. The ones that don't have this oily coat around them, they will be very much more immune to the effect of these sanitizers than these enveloped viruses like coronavirus. It has an envelope around the outside that makes it susceptible. To get round that, you can always use soap and water. And in fact, in studies, soap and water usually emerges as the best way to clean your hands. We think that technology is great, and we're so used to saying, well, I'll use all these fancy new chemicals, they must be good. They're often very practical, but good old-fashioned soap and water is often much cheaper and turns out to be, hands down, the best way to clean your hands.
Now, Roderick in the Strand. Oh. Hold on, let me try that again. Roderick.
Morning, Kino.
How's it? Okay, we can hear you. Talk to me.
Lekker, man. I want to ask Chris, good day, Chris.
Hi.
What is the most intelligent animal on Earth, and is it proven that that animal is more intelligent than a human being?
Well, we all know a few animals that are definitely more intelligent than a few humans, we all know, don't we? The answer is that it depends how you define intelligence, because there are humans on Earth that if you ask them to sit an intelligence test would fail it. And this is because they haven't been educated in the way that enables them to understand, comprehend and engage with the test. So similarly, is an animal that knows how to survive in some of the most extreme environments on Earth and knows how to protect itself from certain adverse weather conditions or tolerate very, very harsh environments, is that animal less intelligent? Or is it just that we don't really know how to judge intelligence? Obviously, humans are judged to be right at the top of the tree of intelligence, although that is debatable because we're probably at the moment sowing the seeds of our own destruction. But we have language, we have the ability to work as a group, we communicate information, we store information, we pass information on down our family tree, effectively building the knowledge in the population all the time, and we look after each other. So humans obviously have one extremely well developed form of intelligence, but then other animals that know, in inverted commas, how to, without any kind of GPS, any recourse to any other tools or maps or anything, take off from one country, fly thousands of kilometers and unerringly arrive at the same place in their destination, and they've made their own way there with no help from us. If a human achieved a feat like that, people would say it was extraordinary. And these animals just innately know how to do that. So I think intelligence comes down to how you define it. And if you want to define it a human way that suits humans, then humans are incredibly intelligent. But I think there are many, many species on Earth that have their own form of intelligence that also stands out and makes them extraordinary.
It's what they call a suitcase word, intelligence. I mean, you can fit anything into it, right? Depends which way you look at it. Here's a smartphone question. Are smartphones changing our brains? How is using a smartphone changing our brain activity in particular, if it does at all?
Well, as neuroscientists are fond of saying, the brain that you wake up with in the morning is not the same brain that you go to bed with at night, because your brain is continuously learning and being shaped and moulded by your day-to-day experiences. So having this interaction between all of us this morning, we are changing the brains of all of us. We've all taken away information, put that information into our brains, and we're going to store, hopefully, some of that information. And we're going to store it in connections between nerve cells. Our brains contain something like 100 billion nerve cells, and they make thousands of connections between each of those nerve cells, and it's those connections, the density, strength and direction of those connections, that stores the information. And therefore, if you learn something, you have changed the structure of your brain. And therefore, if you do anything, you change the structure of your brain. If you interact with, engage, play with a phone, a device, a computer, whatever, you are changing your brain. If you go for a walk and look at the scenery, enjoy the air, listen to some music, talk to a friend, you are changing your brain. Taken to extremes, people have demonstrated that you can change the brain visibly. There was the famous study done on London taxi drivers, where the volume of the hippocampus, which is the part of the brain that is the seat of learning and memory and navigation, the volume of that brain structure was measured in people who were learning to do the knowledge, which is the test that taxi drivers have to take in order to get their taxi license for London. And they have to learn thousands of streets, and they have to be able to, at the blink of an eye, recall perfectly from memory, with no recourse to any kind of map or GPS, how they would get from one location to another location. They're not allowed to get it wrong, and it takes them years to learn it. And in the study where people were measured across the course of doing this learning, the volume of the hippocampus, this brain structure that enables us to navigate, remember where we've been and form new memories, did change demonstrably in those people that went from not knowing the London knowledge to passing their taxi exam, suggesting that and proving that the brain is plastic, moulded and changed by our day-to-day and educational and interactional experiences. And so I would say using a phone will definitely change your brain, and the extent to which you use the phone and what you do with your smartphone will also have a corresponding effect on the brain and on different bits of the brain according to what you're doing with your phone.
Let's move on to attraction, shall we? Does same-sex attraction happen in animals too? Can animals other than humans experience same-sex attraction?
Well, we don't really know, because we don't know if animals fancy other animals the way that humans fancy other humans. If you see someone and you think, wow, I really like that person, you can't explain why you really like that person. I mean, there are certain things that you could say, well, I really fancied my wife because, but you can't explain why her attributes stand out to you compared with, say, another person who's also a very nice person, very good looking. There's something about that person that really effectively clicks between two people. Now, we can't ask an animal, do you find the same kind of meeting of minds with your ideal partner? In the case of my dog seems to want to have relations with any other animal it encounters, and including inanimate objects as well. And so does it fancy those objects? I doubt it. I think these are just instinctive behaviours. We are using those same instinctive behaviours, but we are sort of superimposing on them additional social factors. So I think animals probably do have relationships. They obviously they get together with other animals and some bond or pair for life. They are using instinctive judgment as to what corresponds to the best partner for them in the case of animals that mate for life. And when it comes to same-sex relationships in animals, that's certainly been documented. There were a couple of penguins at London Zoo that made the newspapers in the last couple of years, and there were a couple of male penguins, I think, that were hanging out together, and the staff went and got them a rock to pretend to be an egg so that they wouldn't feel left out when all the other penguins were incubating eggs. And I think they were quite happy with their egg. I'm not sure what they did to fool them into thinking it hatched into something, but they seemed pretty happy to have an egg to look after between these two male penguins. So that there are same-sex relationships that form in animals as well, but whether or not that corresponds to an active choice on the part, or whether something about their instinct just means that those two animals decide that they really like each other's company, I don't think we understand that enough.
No, indeed. And something tells me your dog does not want to take your leg to the movies and get some popcorn.
No.
So, no, without a doubt. Now, Chris, what's your plan for the weekend?
Well, I think the weather here is probably in its last dying days of summertime. So I'm going to try and get some fresh air and enjoy the last ounce of freedom before we all get locked down again, because the L word has resurfaced in the media over here, and people are saying our coronavirus cases are rising. Predictably, we knew they would. Schools are going back, universities are going back, people are going back to work, cases are coming back. I hope we don't end up back in some kind of lockdown situation, but just in case we do, I'm going to go and make the most of it. What about you?
Yeah, same here. Well, I'll be locking down. I've got an honours capstone project due on Monday, so most of my weekend will be
doing some homework
spent behind my behind my computer, weakening my eyes, but growing my brain. Anyway, great chatting to you as always, Chris. Have a fabulous weekend.
Likewise. Cheers, Kino.
Thank you, sir.